All right, let's talk about another possibility. Something like this, these guys. And on the worksheets, what we called these were an opportunity to multiply by the least common denominator. So if you said, well, this could be sine x equals 1 over sine x. And I know what you're thinking. You're going, well, heck, let's just cross multiply. Well, that's the same thing as multiplying by the least common denominator. So if you just cross multiply, you get sine squared is equal to 1. So sine is equal to plus or minus 1 when you take the square root of both sides. Then you could look at it and say, okay, when does sine and cosecant? Well, sine and cosecant are equal to 1 and -1 at the same time. Well, that'd be pi over 2 and 3 pi over 2. And that's pretty logical. I hope it's logical, because this would be sine of pi over 2 is 1, 1, and -3 pi, 3 pi over 2, this would be -1, -1. So anyway, they both check. Okay. Now in a situation like this, you're thinking, uh-oh, this could be a little bit messy. But how about this? How about if we multiplied everybody by cosine, aka the least common denominator, or think of it as cross multiplying the cosine. So if I multiplied everybody by cosine, okay, so I'm happy. And then I think, well, all right. On the previous material, we said, well, we can move the sign over because we definitely want to set it equal to 0. Because we love, in a case like this, we love to set it equal to 0. Now the sign will come out. So what do we have here? Sine x equals 0. Cosine square minus 1 is equal to 0. So cosine is equal to plus or minus 1. So when does sine equal to 0? Well, that's good old 0 pi, 2 pi again. Oh my gosh. Cosine is equal to plus or minus 1. That's also, wait a second, that's also 0 pi and 2 pi. And then the question is, well, do these actually check? Because it never hurts to check. With squaring both sides, you definitely have to check, but it never hurts to check. But the whole idea here is, if you plug 0 in for tan of 0 is 0. In fact, tan of all three of these is 0. And then sine of all three of these is 0. So this side always goes to 0 and this side always goes to 0 just by plugging these three things in. So they just go to 0 all the time. Everybody's happy. So it does check. So these are the ones we call, and I'm sure we could piddle around with this and come up with all sorts of different ways to work these problems. But this would be the most straightforward. Right.